Good morning, physics and active physics students. Today is Thursday, September 17th. Couple of notes before I start our discussion on acceleration. The assignment today is to complete some acceleration problems, and I'll go over how to do that in a few minutes here. The two previous days, you should have gone through the information from the physics classroom on acceleration and then filled out that worksheet so you have a little background on acceleration. And then today we'll apply that information to solve some problems on acceleration. So again, your goal is to listen to the video, take in the information, and then go ahead and complete the problem set today and tomorrow. Tomorrow I will post a link for Google Meet, or I might even include it here, but it'll be tomorrow at 10 a.m. for any and all questions on velocity and acceleration. My goal today is to get through some of the material you've turned in, get the grades updated, look at the velocity problems, see if there are any issues there, see if there are any issues with uh, the acceleration worksheet that you completed. So I'll get through that and I can address any of those issues in the Google Meet tomorrow. Also, if you are having any questions as you make your way through the acceleration problems, I will also address those at the Google Meet tomorrow at 10 a.m. I plan on giving you a quiz Monday on velocity and acceleration, and that'll be open from 8 a.m. to 3 p.m. on Monday. Watch for some curveballs there, paying attention to units. You might need to convert using dimensional analysis from one unit to another in order to go ahead and solve the velocity or acceleration problem. Also note a question or two might ask you to put the answer in its proper number of significant digits. If it does not ask you specifically to do that, then you do not need to follow the significant digit rules. And if you have a lot of the problems will wind up having a decimal point, you need to display no more than two numbers past the decimal point. So just a couple of notes there. So let's take a look at the acceleration. And I have the worksheet that you'll be getting open already. So again, acceleration is the rate of change. So when you hear the word rate, you're thinking of time. So it's the rate of change in the speed. Remember, speed is synonymous with velocity of an object. So to determine the rate of acceleration, you use the formula below. So again, if you look at this problem here, remember this is your velocity magic triangle. So velocity is distance over time. Now with acceleration, what we're looking at is the change of velocity over time. And this triangle is, I believe it's delta, Greek symbol for delta, meaning change of. So you're looking at, say, the final speed minus the beginning speed. So a lot of times you'll see it termed the velocity final minus the initial velocity. In this worksheet, you'll see it as 2 and 1. So 2 would be that final, and then 1 would be the initial. But really what you're looking at is acceleration is going to be the final speed minus the beginning speed over time. So that's what the change of means there. You can also rework these, again, taking into account that the change of velocity means, right, you have your final velocity minus your initial velocity. So again, you can if you substitute this up here, you can still solve for any number of these. So if you only wanted to solve for your final velocity, right, you can rework the magic triangle to have it your initial velocity plus acceleration times time, or you can solve for time, right? Time would be v, the final velocity minus the initial velocity, and then divided by a. So no different than this. You just have to remember that the change of velocity really means final minus initial. So again, to give you an example here, a skater increases her velocity from 2 meters per second to 10 meters per second in 3 seconds. What is the skater's acceleration? So again, they give you these nice little boxes here, but again, you're really just spelling it out. What is the skater's velocity? Well, your acceleration is your unknown. Your time is simple. Remember, time comes in seconds. So your time is 3 seconds. She increases, so the initial velocity is 2. So velocity initial is 2 meters per second. And then the final velocity, according again to the problem, is 10 meters per second. Again, this is straightforward. So you've got acceleration is going to equal that change. So you're going to have 10 meters per second minus 2 meters per second, and you're going to divide that by 3 seconds. Another thing to note is that acceleration, its unit, is going to be meters per second squared. Right? That's going to be the unit for acceleration. Remember, velocity is meters per second. If you're talking about a distance, you're just talking about meters, and then time is in seconds. So to solve the problem again, you wind up with 8 meters per second over 3 seconds. And again, you just do the math, and you've got 2.7 meters per second squared. All right, so let's go ahead. Again, they give you another example here. A car accelerates at a rate of 3 meters per second squared. So again, just break it down. So it's telling you already what the acceleration is, 3 meters per second squared. If its original speed, so that's an initial speed, so the velocity initial is 8 meters per second. How many seconds? So that's a question. It's posing a question. So that's really what you're looking for. Time equals that. How many seconds will it take the car to reach a final speed? So here's your velocity final is 25 meters per second. So again, what you're solving for is time. And again, you can see to solve for time, right, according to your magic triangle, up here, you have your change in velocity over your acceleration. So you're just going to plug in your numbers. And again, here they are. You've got 25 minus 8, which is going to become 17 meters per second divided by that acceleration. Right? And really, you don't need to worry about the canceling out and setting up these units. If you know you're looking for time, you know that your end unit is going to be seconds. So really just focus on the math. So you've got 17 divided by 3 is going to come out to 5.7 seconds. So again, you really want to take your time, create, say, a Google Doc. Hopefully you're using it in Cami. You know, if you're using it with a stylus, I don't know, I find that easier. But again, you want to break your problems down here, listing out what is being given, determining what you're looking to find, setting up your equation based on what it is you're finding. Remember your magic triangle. So again, you've got acceleration is the change of velocity over time. So again, problem one here is kind of giving you the box. Just go ahead and do that with problem one. And you don't necessarily have to use the box, but I do need to see this information here as you do your problems. You have no space here to do it, so you're going to have to set it up, do a blank document in Cami, make sure you number it, make sure you're listing out what's given, what you got to solve for, and then go ahead and solve the problems. And again, at this point, problems for some of you may seem a little simplistic, but again, getting in good habits of putting all this information out is going to be key, because as we move into next week, we'll look at a little bit more difficult acceleration problems where we'll have 3 more additional equations. So for physics, you're going to look at what I just did. Get rid of that. Physics, you're going to be doing problems 1 through, you're going to do all of them. You're going to be doing 1 through 11. So once you get going, you'll be fine. And then active physics, I inadvertently put an S there. You're going to be doing 1 through 8. All right, so you've got today and tomorrow to complete these. Please, you need to show up tomorrow if you have questions, or even just show up to say hi to the Google Meet at 10 a.m. I'll put the link in. I'll post this video. Email me with any quick, direct questions. If not, jot them down. Do all the setups. See if you can get through all the setups today, and then we can address any questions you might have on this problem set or anything with velocity or acceleration tomorrow. Have a good day and get busy doing physics.